In this video, we're going to talk about the time value of money. So I'm sure we've all heard of the saying, time is money. Obviously, many of us sell our time in order to make money. That's one way in which time is money. But also, with the passing of time, our money becomes worth less in the future. And the primary reason for that is because the cost of goods go up. We call that inflation. And as the cost of goods go up, our money doesn't buy as much. Unless, of course, you can invest your money in order to generate returns that are higher than the cost of inflation. That's called real returns. It's the difference between inflation and the rate of return that we get. So in this slide, there are two formulas that we use to adjust money for time. And the first one is FV stands for a future value. So if you make an investment and you multiply whatever this investment amount is by 1 plus a growth rate, some determined growth rate that you think your investment will grow by, and you do that to the power of years that you are invested in that investment, you can determine what the future value of the investment will be. We'll do some calculations on this shortly. So future value is looking forward, and present value is taking some cash flow that you might receive in the future, or it might even be a series of cash flows. And instead of multiplying like we did with future value, we divide. And this time we're going to divide by something called a discount rate, 1 plus a discount rate. So we might use inflation as a discount rate to see how our money loses value. But we might use a discount rate that maybe represents the riskiness of an investment or project from which we are getting these cash flows. We might use the cost of capital, and we'll talk more about that later. And again, it's to the power of years, and that's how we get the compound effect of this. So let's see how this might work. Here's a very simple example. So we're going to go to our local retailer, and we're going to buy a trolley load of goodies, 1,000 rands worth. Mind you, these days 1,000 rands probably wouldn't fill a trolley, maybe just a basket. But I'm interested to find out that these same goods that I'm purchasing here, what will they be worth in 5 years' time? Rather, not will they be worth, but what will it cost me to buy them in 5 years' time? And for this example, if we assume that inflation is 6%, well, it will cost us 1,338 Rand and 23 cents. So how do we do that calculation? Well, we do that using the future value or present value formulas that I showed you a moment ago. So I'm going to bring into picture a spreadsheet that can help us do these calculations. So here's the problem we're faced with. We're spending 1,000 Rand today. We're assuming that inflation is 6%, and we want to know what will these goods cost us in 5 years' time. So I've simply just put these components into my formula. All right, so if you look at my formula components, the 1,000 Rand is the cash flow, the 6% is the inflation, and 5 years is to the power of time. And if you do that calculation, you get here 1,338 Rand and 23 cents. Now we could do the calculation backwards as well. We could say those goods in 5 years' time for which we pay 1,338 Rand, what would we pay today? If we were given the 1,338 and we had to reverse engineer it, we could try this formula. We could say if 16 is the future value and we are going to divide now instead of multiply by 1 plus the inflation rate to the power of time, and this is just a reverse engineering of the formula, or reverse calculation using the future value and the present value to show how these variables impact the results. So that's a very simple way of using it, and that's a way that we can use the formula. We may choose not to use the formula. We might decide that let's use a present value table where they provide us with some data that we might use to simplify the calculation. So let's see what's going on here. This is the present value factor of $1 per period at I percentage for n periods. That sounds quite complicated, but really what it's doing is it's saying here down the left hand side are 50 different time periods, we might say 50 years, and here across the top are different discount rates or different percentages, and we might use, if we use 6% here, we might say, well, what if we discount our 1,000 Rand by, or let's say 1,338 Rand by 6% over 5 years, we would use this percentage here of 0.747. Let's do a quick calculation here. So that was 0.747, and if we said take that number and multiply it by that ratio, well, we're going to get very close to 1,000 Rand, give or take a rounding error in this ratio number. So instead of using the formula to get us back to 1,000, we might use a factor to get us back there. And really the way these factors are calculated, if I show you my NPV table here, if we have a look at this formula, we will see this formula is taking 1 Rand or $1 according to the table. It's dividing it by 1 plus G2. There's G2, it's the 6%, so divided by the inflation rate to the power of A7, which is the power of 5. So to get this factor, they are in fact using the present value formula to do it. So instead of us doing the calculation, we're just multiplying by the factor. So that's another way of doing this. So what I would like to do is I'd like to introduce you to some numbers that we might use to demonstrate how we use this information. So I've called this an NPV example, and I'm going to show you effectively 5 years worth of information for an investment that this company is considering proceeding with. And this investment requires this company to spend 200 million Rand. These numbers are in millions, and let's assume for our purpose it's in rands. It's required to spend 200 million Rand to acquire certain assets that the business needs in order to generate cash flows. And the business has determined that in the future, by using these assets, they will generate in the first year 100 million, in the second year 120 million, 130 million, and in year 4 150 million. So these are the forecasted cash flows that are expected from investing in this asset. So how do they get to these cash flows? Well, that's a whole exercise in the financial planning, in determining who is the customer, what sales are you going to make to the customer, how does that translate into cash flows when you take into account all the expenses. And this is the output of a comprehensive planning exercise. Now, what we've learned is that these future values that we are going to generate are worth less because we earn them in the future. So they are worth less in comparison to each other and specifically they're worth less in relation to the 200 million that we're going to spend now. So in order to determine if this project is feasible, we need to make adjustments to these future cash flows in order to find out what is today's value of these future cash flows. And let's find out if the sum of these future cash flows, which is 500 million, is that more than the 200 million after we've adjusted for the time value of money and for any inherent risk in the project. Okay, so I'm going to discount these future cash flows at 20%. So if we say in South Africa a cost of capital that might be reasonable to use for a business is 18%, I'm suggesting we use 20% because maybe this is a small medium enterprise. It's more risky than a listed company. So 20% discount factor, or if you want hurdle rate, to use a different language, we want to generate returns that are higher than 20%, is an appropriate number to use. So we could then say, well, take this 20% and let's go to the table and find out what these factors are. Okay, so let's do that. Let's go to our table over here. And if I find the right table, there we go. Let's go to our table and let's look here at 20%. There they are, 0.833, 0.694, etc. We're going to use those four factors in order to discount our future cash flows. So you'll see that's where these numbers come from. That's where these factors come from. So now what I'm doing is I'm multiplying the cash flow by the factor to get the present value. Because this money, this 200 million, is being spent now in this year, well, we can say multiplied by 1, it's worth 200 million because this is already present value. But let's go and get the present value for the 100 million that we are going to earn next year. Multiply it by the factor and you get the present value. And we repeat this process for each of the years, and this is the discounting process, if you want, in order to determine what are the future cash flows after they've been discounted and after we've adjusted for inflation and risk. Now what we're going to do is we're going to sum these. So if you look at my formula in there, it's literally doing a sum. It's saying we're starting with minus 200 and we're adding these adjusted future cash flows in order to find out what is the net present value. And because this net present value is positive, what that means is that these future cash flows, if we look at our sum down here, these future cash flows are 314.24. Now, of course, we got to subtract out of the future the minus the 200, and hence we get to 114. And what this is in fact telling us is that our project is a good project to proceed with, because we're going to generate returns that are higher than 20%, and therefore, as a result, our net present value will be positive. So the way we can demonstrate this is here on the right. It's a simple graph which has the years going horizontally and here the cash flows going vertically. And in year 0, you can see this goes down to excuse me, minus 200 to show the first outflow, and then the sum or the individual cash flows as time passes, and eventually we get here to the end, and the value on the last point there is 114.24. So because this line has got above the horizontal, therefore it's a good result. We've earned more cash flow in the future than what we paid out today to get the project underway, and that represents a good return on investment. Now, Excel can also do this calculation for us. And you'll see here in my cell next to Excel's NPV calculation, Excel has a formula here where I've taken these cash flows and I'm discounting them by 20%, and I'm calculating Excel's version of my NPV, and of course I'm getting the same answer. I should get the same answer. Now what I could do is I could say I want to find out what must this discount rate be at the point at which this NPV is 0. So we could do a series of iterations. We could say, well, what if we made this 30%? But if you increase the discount rate, you're going to get a different factor, and the discount effect will be heavier, and therefore the NPV will be lower. And you'll notice here with the graph, this has ended at a lower point, 59,62. Now we can do a series of iterations. We could say, what happens if this is at 40%? And you'll notice this is heading down towards 0. We might say 45%. And what if we said 45,8582? Well, you'll see this number comes all the way down to 0. And the graph shows the cash flows going from minus 200, finishing exactly on the horizontal line. So if the project looked like this, we would pay 200 million today, and we would just earn back the cost of investment. We wouldn't actually make any profits from it. And you might say, well, all we've done is we've covered our risk. We actually haven't made any money out of this project. Well, then we wouldn't proceed. However, we would still be getting a 45% return, which is a good return. But at 20%, we just wanted to do better than 20%, well then this is a very good project and we should proceed with it. Alright, so I hope that gives you a quick overview of how we use NPVs and discount rates and time value of money, and in the next video we'll put this into practice and you can see how you can apply it in a practical way.